Where do you want to sit? We have to do B5 first. Yeah. B5, here we go. Draw a diagram that shows the amplitude of the vibrations of the air particles at the first position of resonance when the fundamental mode of vibration occurs in a pipe closed at one end. Okay, so for this is A part 1. So here is a node, and here is an anti-node. So the sound wave looks like that, and is vibrating here. Okay, that's the first one, and the second one. So I always like to put a little bit of sand in my picture. No, I don't think so, because it says here fundamental means the first resonance. Yeah? So what you drew, I think, is the second, huh?
It says air particles in the first position of resonance when the fundamental mode of vibration occurs. It's the same thing, right? They're repeating themselves, it's nothing different, right?
Possibly. I haven't fully read it. I just want to draw everything. Yeah. Oh, nice. Congratulations. Displacement. I always like to put in this graph as well, displacement of sand. If you put some sand at the bottom of the pipe, then it will start to build up at the end. I like it. They didn't ask for it, but I like it. I think they just want this. We've done this one many times. Okay, next. In an experiment to measure the speed of sound, a note of frequency 512 was sounded above the open end of the air column and closed at the other end. The first position of resonance was at 0.162 and the second was 0.494.
Do we need that graph?
Which one?
The bottom.
What did I say? What did I say?
I was copying it down. I didn't hear you.
Thinking of somebody, weren't you? You weren't listening to me.
I was thinking of that.
No, you weren't. Were you? No, you don't need it. I like it. I like it. So draw it. You don't need it. Oh, no problem. Right, part 3. So we have, in this picture, the pipe is 0.162 meters. And then in the second picture, it's longer. It's 0.494. The first one is the first resonance, and the second one is the second. So in the first picture it looks like this. You have a node, antinode, and goes like that. And then the second picture, it's the second resonance. So that's like this. So in this picture, the wavelength would equal 4. Screw it over. In this picture, the wavelength would equal 4 times 0.162. And in this picture, the wavelength, I'll write down wavelength 1 and wavelength 2. That would equal 4 times point, no, not 4. It would be 4 over 3. 0.494. Yeah? 4 times 0.162. 0.648 meters, and in this one, 0.6587 meters. Now that's not finished, but is that okay so far? Yeah.
Which
This is part 3 here, part 1.
did you finish problem?
Huh?
Is it finished?
Oh no, not finished. Not even half finished. Continue. So if I just go to the side here, it's okay? Yeah. If I go to the side here, we have V equals lambda F, which is what we want. So in this one we get V equals lambda, which is this one, 0.648. Lambda F, which we're told is, where is it? 512, yeah. And then the second one, we have V equals 0.6587 times 5112. So, what's the problem here with these two lines? What's the problem? Yeah. Well, this is supposed to be the speed of sound, right? But we should get the same answer for both. And we get nearly the same answer for both.
Yeah.
We don't get exactly the same answer for both. We get nearly the same answer for both. Yeah. So like in the first case, the answer for the speed of sound is 332 or 331.8 meters per second, and in the second case it's 337.3 meters per second. So you know from doing your physics and chemistry, when you have more than one answer, what's the best answer to use?
Average.
The average, yeah. So we'll do 33.8 plus 337.3 divided by 2. And we get a final answer of 335.6 meters per second. This Continue. So part 2 is they want to know the error, the end correction, the error. So that was part 1 of it, and then this is part 2 of it now. So the reason, do you remember why the reason that they're not quite the same? Frequency is actually the same, 512. It's to do with the wavelength. So if we go back to this picture, we said that the wavelength is 4 times the length. But what really happens in real life is that it doesn't quite match up. It's like maybe it's a little bit bigger or it's a little bit smaller. So the problem is at this part. There's like an error here, because when you put the tuning fork beside the pipe to make the sound wave, it's not a perfect fit. So this is where the error is with the lambda. So really our equation should be like this: V equals 0.648 plus error times 512, and V equals 0.6587 plus an error times 512. No, I'm sorry. The error is, I put the error here, but I'm thinking maybe I should have put it.
What is the error?
We have to calculate it. The error is because the sound wave doesn't match up perfectly with the pipe. Sorry, do I put the error here or do I put it inside this? I'm trying to remember. It is outside.
I think it's
Which part?
Why is
It's about
because you have to tie it together with the fork.
1 2 wrong, or maybe it's the whole one.
Let me think.
But the error after calculate the exact
But the error is in the length.
The error is in the length. But I just wonder if I should add it on after or before I multiply by 4.
it's nothing.
It's a little bit different. Let me double check it on the internet.
Guys.
No, I don't think I can call anyone to help.
Mark.
Mark? No.
Maureen.
No.
Sorry, that's something else.
I mean, you can almost see that whatever it is, it must be very small, because these two answers are very similar. So the answer must be very small. I don't feel like I should. Should I add it here? I really, inside my heart, is telling me that I should have it on the inside with the 0.162. I feel like I should have it in here.
Oh, yeah.
Yes, we'll see. Well, if it is that, let me just write this out again. The 0.648, that was 4 times 0.162. 4 times 0.162 times 512, and then V equals, and the other one was 4 over 3 times 0.494 times 512. I think the error is when you're measuring the length, the 0.162. Do you understand what I'm saying? That the error should be inside this bracket here. So it makes me feel like I should put the error in here. We'll just double check. End correction resonance tube. Useless.
Should just type the error.
What do you mean?
Just when you type in search.
Yes.
You
I say error, but the real name is correction. Yes. The error, which they call D, you add it to the length of the pipe. Yeah. So, yes, my heart was right. I should add it to the length of the pipe.
Should we write this in Excel?
This?
No.
Oh, yes. Yeah. Oh yes, it's this part here. Part 2 here. Yeah. Right, okay, so we get here B equals when you multiply it out, 333.8 plus 4 times 5.12 plus 2048 E. I think that's right. And then the next one will be V equals 337.3 plus 682.7 E. So I can just write this as 2048 E minus I'll bring to the left. V minus 2048 E equals 333.8 and V minus 682.7 E equals 337.3. Now I get the answer here. It's just a maths problem. Nice. So when I solve this, I get V equals 339, which makes me very happy because the true answer is, I think, 340. And then the error, should this be a big number or a small number? And it is. It's 2.56 millimeters is the error in measuring the pipe. Put in here pipe error. So the important note, which is for me and for you, is that the E goes with measuring the length. So it's like is like this, that the error is here. And I should also write that most books use D. It's just that I like to use the E. But maybe I should use D. It'll help me to remember it's for the length. Is that okay? Yeah? Okay, continue. Right, this is in your notes. Superposition of waves. You've seen it in physics and I think maybe in your special listening class. Do you remember what this is?
Two waves sine wave or sine wave.
Yeah, that's it. Two waves combine and to form a wave, a bigger or smaller wave. Right, in this one here, for the interference experiment, what are two things you need for the wave? So in the, you know this experiment where you have the double slit. Yeah, what do you need? Yeah, no, but for the wave. No, what about the wave? So
Same frequency.
Yeah. Say again? One more time? I can't hear you with the machine.
No.
No, don't be shy. We're friends. What were you saying?
Direction.
No. Huh? In phase. Remember in phase? No? In phase means the waves move together. That they're not, it's not like they're moving at, do you remember you have this wave and this wave, and these are in phase, they're moving together. No?
I know.
Yes? Yeah, if you look at double slit in the wave section, you also need to look up phase. Is that what you were saying, Sophie? Phase difference? Or you were saying diffraction? Okay, that's okay. Right, is this okay? Yeah. Young's double slit experiment, the two narrow slits are spaced 0.75 millimeters apart. Okay, so let's draw the picture. There's Young's double slit. The D here is 0.75 millimeters. The wavelength is 628.3 nanometers. And then the screen is 1.65 meters away. And then of course you know what happens. You get your dot here, and then dot here, and then dot here. And this is 0, 1, minus 1, 2, minus 2. And the question is, okay, so they want to know how far away is the fourth dot from the center. So they want the distance from here to here. That's what they want. Mm-hmm. Now there are two ways to do this one. You can use, I'll show you here in the formula book. So, let me just call these distances here S, the slit. Oh, I'm sorry, no, they don't call it S, they call it, what they call S, I call D, and what they, yeah, okay. X here. So there's two formulas you can use. You can use this one, except I use a D instead of an S. Or the other formula, which I don't actually think is in the book, which I'll write down for you. Let me just double check. No, it's not in the book. It's odd. The two formulas you can use are this one, which is lambda equals x d over big D, which is this. Or the other one is n lambda equals d sine theta. You have those two you can use. Now the one we should use, maybe we should look at what they ask us to do next, so then we can maybe choose what to do. No, it doesn't matter. So we can use either formula. Okay? From the slit to the screen, yeah. The distance between the slits here. So, if we use this formula, what do we make n equal to? 4. Do we know this? And do we know this? So this gives us, yeah, the theta. So we could draw a triangle. We know this angle, and we know the ground, so we can know the height. But I think the first one is easier because, what would the answer be? The answer would just be, yeah, 4 x's. So we'll just use that one. Here we can get lambda d over d equals x. So that means 4x equals 4 lambda d over d, which equals 4 times 628.3 times 10 to the minus 9 times 1.65 divided by 0.75 divided by 10 power minus 3, and I get 5.53 millimeters. Pretty easy. Continue. Explain what would happen to the interference pattern if one of the slits was covered up. Interesting question. So, if I cover up this slit, so there's only one now, what would happen to the picture? Only one dot, I suppose, yeah. Beforehand, the picture looks like this. This is the before picture. Oh, that's ugly. You get a bright one in the center and then less bright as you go out. If you only have one hole, it would just look like this. It might just one dot. What would happen to the interference pattern if the light, monochromatic light, was replaced by white light? So monochromatic light means one color, like red light, green light, blue light. If it was replaced by white light, do you remember what happens to the picture? Yeah, very good. Yeah. It becomes colourful, yes. Or as Irene said, these become little rainbows. Yeah, rainbow dots, yeah. Oh, Sohi, last night or yesterday evening, I put the physics exams on Moodle that you wanted. Did you see them? Great.
For question number 4, can we just draw that? Because it says like space.
Yeah, give a sentence. I'm too tired to write a sentence. Okay, and the last one? Oh, that was it. Alright. Now the last question. What is gravitational field strength? So do you remember that from the definition? Gravitational field strength is this.
Force
Yeah.
that is from the Earth, the gravitational pull of Earth.
Yeah. Well, it doesn't have to be Earth. It's the force from a massive body.
That has gravity.
Yes, the gravitational force from a body per unit mass. So the formula is G equals F over M, but in words it's the...
It's not G equals H M over R.
That's the other formula for it as well, yeah. Gravity force felt by M in the field per unit mass. You know, so the idea is you have a big M and then you have a small m. So the field strength is the force it feels divided by its mass. Something like this, whatever you have in your definition. The gravitational force experienced by a small mass while in the field per unit mass.
If it's 2 marks, do we have to write 2 sentences?
Yeah, I don't even think I would give me 2 marks for this. It's terrible. You have your notes for a beautiful definition. Yeah?
So if 3 marks, 3 sentences.
Yeah. What's the mass of the Earth if the radius is 6,400? So we can use the other formula you said. What is it? G equals G
Over R squared.
yeah, so M equals G or squared over G, which is 9.81, 6.67, and the radius is 6,400,000. 6.0. Great. Okay. Yeah.
Do you want to double check?
Maybe I trust you, but maybe not. It's different. No, but I think it's... Oh! Dunk. Square. It's correct. Okay. Continue.
What is the G?
It's a constant. It's the same constant in this formula. Yeah. Oh, it should be, yeah. It's also on your calculator as number 36. You have this one, don't you? Yeah. Okay, continue. What's the density? Blah. For babies. Density is mass over volume, which is 6.02 times 10 to the 24 over 4 over 3 pi or cubed. Yep. You got an answer? Let me double check. Yes. 5,486 kilograms per meter cubed. Yep. Okay. So far that's okay. Determine the speed of the moon around the Earth if the time is 27.3 days and the radius is that. Okay, so we have our Earth and we know its mass, and we have the moon and we know the distance. It's 3.84 times 10 to the 8 meters. We also know the time here, it's 27.3 days. And we want the velocity the moon is travelling at. So we have the formula V equals omega r, and omega is 2 pi over t. So, and what unit should the t be in? Seconds, yeah. A big number. 24 hours. 3,600. The radius. One 1,023 meters per second.
What is the omega again?
2 pi over t. It's an angular speed.
And what's the t?
Periodic time.
Right, so 37.3 days changes per second.
Yes. Okay, the next part. Okay. A spacecraft is put in orbit around the moon, which has a mass. Oh, they give you the mass of the moon. Okay. Determine the time taken for the spacecraft to make one orbit when it's 95 kilometers above this. Okay, so in this picture here, can I go down? We have the moon. Its mass is 7.18 times 10 to the 22 kilograms, and there's a spaceship here, and its distance is 95 kilometers, but the moon is 1,740, so the answer would be 1,835 from the center to the center. That 95 is only there. The distance from the center to the center. What do I want? Let me draw it again. Okay. 7.18 times 10 to the 22 kilograms. They give us this distance, the radius, and they also give us this distance here, and here's the spaceship. So the total distance from here to here, I add these two. So 1740 plus 95 is, yes, 1835. So that's 1835 km from here to here. And are we told anything else?
No.
No. So what, if we want the time, what formula could we use here? Do you know? It's a formula that's not in the book. Not in the book. It's one of the few formulas not in the book, because they might ask you to prove it. It's in fields. He has 3 laws.
Oh, Kepler's second law.
Kepler. You've got Kepler's law. There it is.
4 pi squared.
Yeah, so read out the formula.
T squared.
Yeah.
Equals
4 pi squared.
R cubed over G 6 G again.
Do we know the or?
Yes.
Do we know the m? Can we get the t?
Yes.
Yes. Easy if you know what formula to use.
But you did put out
I did that in class. Trust me. T equals 7137 seconds, which is nearly 2 hours. It's 1.98 hours. Huh? Hash browns are good. Continue? Yeah.
I think goose is preferred instead of
Yeah, well, it's fair. Right. The last one is determine the distance from the center of the moon. So they want you to find where P is, so that the force from the Earth and the force from the moon are balanced. Do you understand?
Yeah.
The P is where the forces are balanced from them. So, if we look here, here is Earth, and here is Moon, and here is P. So there's a force to the left and a force to the right. So you want the force to the left, which I'll call Fe, equal the force to the right, which I'll call Fm for Moon. Does that make sense so far? Yeah? So on the left we get G mass of Earth, mass of P, all over. Now,
What is P?
P, what are you talking about? There it is, there.
Yeah, P has no
I know, just don't worry, trust me. So in the picture they say call this distance x. And if the total distance, we'll call the total distance r, then how much would this distance be? It would be r minus x. Okay. So here would be r minus x squared. That equals g, mass of the moon, mass of P, all over x squared. Now, Harim,
Yeah, and this cancel.
what? Say again? What cancels?
The M.
The MP's cancel. So did you need to know the mass? No. And what else cancels? The G's cancel. So you get mass of the Earth over r minus x squared equals mass of the moon over x squared. Yeah? I think I'll multiply. So I'll get x squared over r minus x squared equals mass of the moon divided by mass of the Earth. Now, do we know the mass of the moon and the mass of the Earth? We do. And what was the mass of the moon, please?
7.18 times 10 to the 22.
And the mass of the Earth? 6 point... was one of the answers. Answer 2 or something. Grace, what was your answer? Mass of the Earth?
6.02 times 10 to the 24.
Oops. So we get here x squared over r minus x squared equals 0.011927. What should I do next? Square root. So I get x over r minus x equals square root 0.1092. So I get x equals 0.1092 or minus 0.1092x. So I get 1.1092x equals 0.1092 or. So I get x equals 0.1092 over 1.1092 or. So I get x equals 0.09846 or. Do I know the distance between the Earth and the Moon? Yeah, what is it? Did they give it to me?
One, no.
Wait, it's from earlier. Here it is, here. This is it here, isn't it? This is the radius of the orbit of the moon is this. 3.84 times 10 to the 8. So the answer here will be 37,800 kilometers, where for the ore it was 3.84 times 10 to the 8. Yeah. It's a little long, but how many marks did you get for it? 6, so that's fair enough. Yeah. Now, will we look at the next exam? Yep.